Okay, ready for another theorem? Here we go. So here's the second theorem for properties, and these are comparison properties, or we call it the comparison theorem. So these are theorems that apply to comparing functions and integrals. Okay, so one says if f of x is non-negative over a closed interval, then the integral is going to be non-negative, which means if we're talking about area, that makes complete sense, right? Because as we understand integrals as area under the curve, if the function is above the x-axis or equal to the x-axis, well, it's going to be 0 or positive. So that's what this is saying. Number 2 says if f of x is greater than or equal to g of x for all x on a closed interval, then obviously the integral of f of x over that range, a to b, is going to be greater than or equal to the integral from a to b. And that should make sense because, again, we're talking about areas, right? So if f of x is above or at least equal to g of x, then we would expect the area over that same closed interval for f of x is going to be at least as much as the area under the integral, or under g of x over the same interval. Okay? And so number 3 says if we take m and n, some constants, right, such that the value of the function is somewhere between m, lowercase m and uppercase m, for a closed interval from a to b, then this inequality also holds. That if we take the range of the interval multiplied by m, and we take the range of the interval multiplied by capital M, that the area under the curve is going to be somewhere between these two numbers. Okay, so think of this as a rectangle, right? We've got a smaller rectangle, right? This is the height times the base of the rectangle. This is another rectangle, capital M times the base, right? So we're basically taking two different rectangles, right? Because again, f of x is between the height of this rectangle, the smaller rectangle, and the height of the bigger rectangle, right? And so if we look at the area, then we're saying that the area of the function over that interval is going to be somewhere between this rectangle, the area of this rectangle, and the area of that rectangle. So again, in the understanding of areas, these three conclusions make sense. Okay. Have a great day.